Hey everyone, welcome back to Generative AI. I hope your day has been going well. I was in my home office this morning, sipping coffee and checking my notifications, when I saw an alert about something called UHOH AI. Instantly, my curiosity was piqued. What is UHOH AI and why does it matter? If you're like me and eager to explore new AI developments, stay tuned because this could be an important shift in how we design intelligent systems. Over the past decade, AI has evolved rapidly. We went from basic rule-based chatbots to deep learning models that can translate languages, generate artwork, and even write coherent text. Yet many of these systems share a common flaw. When they encounter data vastly different from their training examples, they can produce confident but wrong answers. Those uh-oh moments where AI simply fails can have serious consequences in critical environments like healthcare, autonomous driving, and finance. UHOH AI aims to address exactly that gap by anticipating anomalies and responding gracefully. At its core, UHOH AI is a framework that anticipates when a model faces unfamiliar inputs and doesn't try to fake confidence. Instead, it invokes a protocol to handle the unknown. This begins with uncertainty quantification. Traditional deep neural networks output probabilities, but those numbers often don't reflect the model's true confidence. UHOH AI layers additional metrics on top of standard outputs, measurements like predictive entropy, Monte Carlo dropout variance, or deep ensemble disagreement. By combining these methods, the system gains a better sense of when it truly doesn't know. For example, imagine a medical diagnosis model trained on common imaging data. If it receives an X-ray from a rare pediatric condition unseen during training, UHOH AI's detection modules would notice high uncertainty. Rather than producing a definitive and possibly incorrect diagnosis, the system flags the input as anomalous. It then triggers a fallback process, perhaps alerting a specialist, requesting additional tests, or activating a secondary model trained on rarer conditions. This way, the system prevents potentially life-threatening mistakes by acknowledging its limitations. Anomaly detection forms another pillar of UHOH AI. Techniques range from statistical outlier detection to advanced autoencoder-based methods that spot subtle deviations in high-dimensional data. UHOH AI often combines multiple detectors across different data streams. In a self-driving car, for instance, sensors like cameras, LiDAR, and radar generate vast quantities of information. UHOH AI runs anomaly checks on each modality, detecting irregular pixel patterns, unexpected point cloud distributions, or unusual radar signatures. When anomalies arise, the system pauses and reassesses before proceeding. Juried decision-making enhances this robustness by incorporating ensembles of specialized models rather than relying on a single monolith. Instead of one model handling every possible scenario, UHOH AI uses committees of submodels trained on different slices of data. One submodel might excel at recognizing traffic signs, another at interpreting pedestrian gestures, and a third at gauging environmental conditions. When a novel situation arises, each submodel votes on the best action, and voting weights adjust based on real-time confidence metrics. If submodels disagree significantly, UHOH AI defaults to a safe fallback, such as slowing the vehicle or requesting human input. Explainability complements these features. Whenever an anomaly is flagged or an uncertain decision arises, UHOH AI logs the relevant internal states and provides human-readable explanations. It highlights which input features triggered the alert, outlines disagreements among submodels, and suggests possible next steps. In healthcare, for instance, the system might display which imaging regions were considered suspicious and show confidence scores from different diagnostic models. This transparency helps clinicians understand why the AI flagged the case and fosters trust in the system's reasoning. Human-in-the-loop collaboration is fundamental to UHOH AI's design philosophy. When uncertainty crosses a threshold, the system escalates to human experts who receive a concise summary of the issue and recommended actions. These experts can validate the AI's suggestions, override decisions, or request further data collection. Their feedback is then recorded and used to retrain models, gradually reducing uncertainty in similar future scenarios. Over time, the AI learns from human corrections, improving its ability to handle edge cases. Privacy and security remain top priorities. UHOH AI minimizes the need to share raw data by performing initial anomaly detection on device or at the edge. Only when cloud-scale resources are necessary does the system send encrypted, aggregated insights rather than complete datasets. In healthcare settings, patient records remain on secure hospital servers unless needed for intensive analysis. In finance, transaction data is anonymized before being used to refine fraud detection models. These safeguards ensure sensitive information stays protected during anomaly detection processes. One compelling demonstration of UHOH AI comes from disaster response robotics. Autonomous drones and ground robots navigated a simulated disaster site filled with debris, smoke, and unstable structures. Each robot ran UHOH AI at the edge to detect hazards, gas leaks, hotspots, or sudden structural shifts. When a robot encountered dense smoke it hadn't seen before, the anomaly detectors flagged an uh-oh event. Instead of pressing forward, the robot retreated to a safe distance and requested an alternate sensor sweep, preventing possible damage or data misinterpretation. From an academic perspective, UHOH AI integrates the latest work in meta-learning and transfer learning. By training on diverse source tasks, the system generalizes better when encountering new tasks. Meta-learning frameworks help UHOH AI quickly adapt detection algorithms with minimal new data, crucial when labeled examples of anomalies are rare. Transfer learning allows the system to leverage knowledge from related domains. A medical anomaly detector trained on adult data might adapt more rapidly to pediatric cases by fine-tuning on a small set of examples. Developing UHOH AI requires a multidisciplinary effort. Data scientists design and implement uncertainty estimation and anomaly detection pipelines. Software engineers build reliable distributed systems capable of real-time inference and seamless human handoffs. Domain experts set critical thresholds, define fallback protocols, and guide human-in-the-loop workflows. Ethicists and legal specialists ensure that data usage, decision processes, and transparency mechanisms comply with regulations and uphold user rights. Only through close collaboration can such a robust framework be realized in practice. Rigorous testing ensures reliability. UHOH AI undergoes extensive simulation tests across diverse edge cases. In autonomous driving, virtual environments present erratic pedestrian behavior, sudden road hazards, and inclement weather, verifying that anomaly detectors activate when needed. In medical imaging, synthetic abnormalities and rare disease patterns test diagnostic models' ability to identify unusual cases. E-commerce platforms use adversarial transaction data to check that fraud detection models catch suspicious patterns. These stress tests build confidence that UHOH AI responds appropriately to real-world challenges. Continuous monitoring after deployment improves resilience. Logs of detected anomalies, model confidence metrics, and human overrides feed back into the system. If certain scenarios trigger frequent uh-oh alerts, engineers refine detection sensitivity or augment training data. When human experts consistently override a submodel's suggestions, UHOH AI flags that module for retraining or replacement. Over time, this feedback loop reduces false alerts and enhances overall performance, making the system more reliable and trustworthy in dynamic environments. Human factors play an important role in adoption. UHOH AI aims to strike a balance, alerting users when necessary without overwhelming them with constant interruptions. If prompts come too frequently or explanations become too technical, operators may experience alert fatigue. Designing intuitive user interfaces is essential. Clear, concise explanations, well-structured feedback forms, and responsive communication channels between AI and human experts foster collaboration. Training programs help users understand how to respond to alerts and provide meaningful feedback for system improvement. Ethical considerations are paramount. Anomaly detection systems processing personal health data or private financial records must protect privacy and prevent misuse. Clear policies should outline who can access logs, how privacy is maintained, and what recourse users have if the system commits an error. Transparency about limitations, such as scenarios where UHOH AI might struggle, is critical. Users deserve to know if the system cannot handle a particular type of input and what fallback options exist. Building trust requires candid communication about both strengths and boundaries. Scalability is another challenge. UHOH AI systems must handle enormous data volumes in real time, from streaming video feeds and sensor arrays in industrial settings to high-frequency trading data in finance. Efficient algorithms and optimized hardware become crucial. Edge computing helps reduce latency, allowing initial processing at the source. When deeper analysis is required, intelligent routing directs data to powerful cloud resources. Balancing costs associated with edge devices, cloud infrastructure, and network bandwidth requires careful design to keep deployments affordable and effective. Energy efficiency also matters. Running complex neural networks and anomaly detectors continuously constrain device batteries in mobile or embedded applications. UHOH AI leverages lightweight models for on-device processing, reserving heavy computations for the cloud when connectivity allows. Techniques like model quantization, pruning, and dynamic inference help reduce power consumption. In data centers, mixed precision training and hardware accelerators optimize for performance per watt. By prioritizing efficiency alongside accuracy, UHOH AI supports sustainable deployments in resource-constrained environments. Regulatory environments are evolving to address AI risks. As governments and industry groups propose guidelines for AI transparency, safety, and accountability, UHOH AI aligns well with emerging standards. Its emphasis on uncertainty reporting, human-in-the-loop review, and audit trails supports regulatory compliance. Organizations adopting UHOH AI can demonstrate governance practices, logging decisions, tracking data usage, and providing evidence of fallback procedures. This accountability not only fosters trust with stakeholders, but also paves the way for smoother regulatory approval in sensitive sectors. In practice, UHOH AI could transform many industries. In manufacturing, assembly lines fitted with intelligent sensors could detect early signs of equipment failure, unusual vibrations, temperature spikes, or power irregularities. When anomalies arise, the system warns maintenance crews, preventing costly downtime and accidents. In smart agriculture, networks of soil, moisture, and weather sensors detect unusual patterns like unexpected frost or pest outbreaks. UHOH AI triggers targeted alerts, enabling farmers to respond quickly and protect crops, improving yields and sustainability. In retail, stores equipped with computer vision systems monitor customer behavior patterns. If a sudden rush of shoppers enters from an unexpected area, or if inventory sensors detect unlisted items moving, UHOH AI flags potential issues: overcrowding, theft, or inventory misplacement. Store managers receive real-time notifications and can intervene proactively to ensure store safety and operational efficiency. In energy grids, UHOH AI systems analyze power usage, detect unusual spikes or drops, and alert grid operators to rebalance supply before outages occur, increasing reliability for consumers. Consumer applications also stand to benefit. Personal assistants running UHOH AI on smartphones or home devices can detect when voice commands or contextual data fall outside expected patterns. If you ask for directions to a location that doesn't exist, the assistant calmly explains that it can't find that address and offers alternatives. If a fitness tracker notices an unusually high heart rate during rest, it suggests a prompt check or offers to call a medical professional. Instead of blindly providing information, the system adapts based on context and uncertainty. Education may see UHOH AI-powered tutoring systems that adapt to each student's learning curve. If a learner attempts problems far above their current level and repeatedly fails, the system detects that mismatch and adjusts the curriculum, providing foundational exercises before advancing. When students explore novel topics, AI tutors could acknowledge knowledge gaps, offer curated study resources, or connect them with teachers for further guidance. This personalized learning journey encourages growth while preventing frustration, making the educational experience more supportive. Of course, UHOH AI will evolve over time. As more real-world data flows through the system, detection modules will become more precise at distinguishing benign anomalies from critical threats. Meta-learning approaches will let new models learn from limited labeled anomaly examples, improving fast adaptation. Advances in federated learning will allow UHOH AI to collaborate across devices without centralizing data, preserving privacy, while enhancing detection capabilities. All these innovations feed into a virtuous cycle of continuous improvement, making the framework ever more reliable. Imagine UHOH AI in personalized home assistants that notice unusual sleep patterns, suggest caring message or prompt to call a loved one. Or picture smart public infrastructure that detects abnormal traffic flows and automatically reconfigures signals to improve safety. These ideas truly show UHOH AI's promising future. I'm genuinely excited by the potential of UHOH AI to reshape how we think about intelligent systems. Rather than punting anomalies to the margins, it puts uncertainty at the center, acknowledging that edge cases, rare situations, and unknown unknowns matter. As AI influences more aspects of our lives, building systems that know their limits, ask for help, and avoid overconfidence becomes essential. UHOH AI embodies that principle, offering a framework to design AI that collaborates transparently with human partners and navigates complexity with humility. Thanks for joining me today and exploring UHOH AI. If you found this overview enlightening, please give it a thumbs up and share it with friends. Subscribe to Generative AI for more deep dives into emerging AI technologies. I'd love to hear your thoughts. What applications of UHOH AI excite you most? What challenges do you anticipate? Leave your comments below, and let's continue the conversation. Until next time, stay curious, stay safe, and let's build AI that knows when to say, uh-oh.